Okay, thank you. Thank you for coming to my talk. My name is Daniel Tobin. I am currently the security lead at Cyral, a data layer security company, technically based in Redwood City. I've been working in DevSecOps since before the word existed, across DevOps, security, system administration, network administration, etc. I actually spoke in person at a conference, what seems like decades ago at B-Sides San Francisco in February, talking about working together with QA teams and breaking down barriers between security and other teams. You can follow me on Twitter at DanT24, on LinkedIn, etc. So what are we going to talk about? So we're talking about a cloud source guide to cloud data security. So I'm going to go through some of the cloud sources that I followed to put together this talk so that you can follow them as well. We are going to talk about why this matters. And then we are going to go through a number of different open source projects that you can implement today if you want, or tomorrow. It all runs together since we're all working from home. And then we're going to talk about a brand new open source project that Cyral has just released. Talk about some of the documentation that is already out there that is actually good in 2020, and then I will open it up to questions. So what are some of the cloud sources I used? So one of the top ones is Clint Gibler's TLDRSec newsletter. He publishes this every week, and it covers everything from AppSec to red team to blue team to container scanning and everything under the sun as long as it relates to security. Another one that is highly useful, especially if you're interested in this talk, is Marco Lencini's Cloud Sec List, or his Cloud Security Reading List. He goes over the past week of what has happened across the different cloud providers, because there is so much changing, it's impossible to try to keep up, whether it's AWS, GCP, Azure, etc. And then, of course, Twitter. Again, you can follow me on Twitter, DanT24. So what are we talking about? So we are talking about the data. Data breach notifications or news stories seem to happen almost daily at this point, if not more than once a day. So instead of like taking the normal sort of thing, like splashing a bunch of different headlines across this, we've all seen these headlines, so I decided to take a look at Shodan to take a look at a snapshot of the current status of just openly exposed data. Like, where are we today? Like, literally today. Well, actually, mostly from yesterday. If you haven't heard of Shodan, Shodan has servers located around the world that crawl the internet 24/7 and provide intelligence on everything that's connected to the internet. And they provide a handy search form so that you can search all of it. You can say, like, I want to look for Mongo servers. I want to look for IoT devices, either via command line or via their website. So as I was looking through the databases, I noticed that they had published this article in 2015 about open Mongo servers, because 2015 was all about open Mongo servers. At the time, this article is still up, they had found approximately 30,000 open MongoDB servers. So I figured, well, let's do a comparison. We must have gotten better in the past 5 years, right? 76,000. So as you can see, this is from page 5. That's how long it took me to get to a multi-gigabyte database. The article previously was announcing these cool graphics that they actually started to surface. So on page 5, we can see that there's a 4 gigabyte database. And the second one at least says authentication partially enabled. You can dig into these and remove the authentication partially enabled, but I'm also just surprised that anyone would leave Mongo with or without authentication up. They break it down into different country hotspots and then organizations as well. We can see that China leads the way, USA is number 2. And similarly, Alibaba leads the way with Amazon close behind, and then after that, DigitalOcean. So, I mean, Mongo, that was cool, 2015. So what are we looking at today? Elasticsearch. Everything seems like every other day it's an Elasticsearch instance that someone has left open for a data breach. But what they did was they just spun it up, import a bunch of data, and then forgot to put security on it. So did you know Saturday was actually International Cat Day? Someone has actually been celebrating for the past couple weeks, though, helpfully fixing these types of instances of open Elasticsearch, etc. Going through and actually zeroing out indices. If you look closely at this one, you can see that some of the Elastic indices have a bunch of letters and numbers followed by meow. So the meow bot has been going through, looking through Shodan, etc., to find Elasticsearch, and has started to branch out from there to actually helpfully fix all of these. All we can see is that these numbers are going up. We haven't seen who the bot is or why or what, but as of yesterday, there are 21,000 results for meows. And this number is increasing by the minute, by the hour. It looked like it was just Elasticsearch at this in the beginning, but as you can see, they started to branch out and be helpful for Mongo and possibly Splunk and a few other ones as well. This is currently ongoing. Hopefully, if you have an open data source, it has not been hit by this. And if you do, you should probably secure it as soon as possible. So we looked at a few numbers around the total results in Shodan, but what about the amount of data exposed and how has that changed? Turns out HDFS, the backing file system for Hadoop, etc., dwarfs Elastic and Mongo database by size. That huge red line, that represents 13.1 petabytes in 2020. Yes, petabytes of just open data up for anyone that wants to take it and transfer it to their own cloud provider. As we can see, comparison over 2018, that's up almost threefold from 5.1 petabytes. And Elastic is trying really hard. They are up to nearly 3 petabytes total. These numbers are all from May, so I would be curious to see what these updates look like now that Meow has been going around, but I haven't seen any updates from that. So the other thing we can't forget about, of course, is S3. One of a helpful website that you can look for open buckets is called buckets.greyhatwarfare.com. You can search for it in Shodan, but this gives it a much more niche view of just S3 buckets. Of course, now S3 can be public for backing of a website, etc. But there are plenty of interesting things if you look through here, and I'm not just talking about all the cat memes and other pictures. This is freely available. They give you you can search for something like a third of their open buckets without even registering. They do have a paid option as well. So AWS, that seemed to be like the number 2. That's one of the biggest cloud providers. How do we go about securing it? As you can see, they have made a ton of effort here to give you a ton of different options in different services to identify, protect, detect, automate, respond. But where do you start with this? And as Quinny Pig says, like, it's probably just easier to just leave things open, and maybe Meow will take care of it. Speaking of AWS, like, how many different services are there? So this is a data visualization that Scott Piper did from Summit Route, visualizing the total number of API calls per service broken out per the console. That yellowish orange in the kind of top left, that's just EC2. I still don't know what most of these are, but there are a lot of different services across AWS alone. I'm not a specific expert in deep diving in any of these, but the last two guys are. I would highly suggest checking them out. Quinny Pig is awesome. He has a ton of great, funny, and useful, and a lot of tweets. So follow him at Quinny Pig, or listen to his couple different podcasts on lastweekinaws.com. One is more snarky, one is more just useful. Scott Piper was the second one. He runs a consulting firm called Summit Route. You can follow him on Twitter, either on his personal /work account or Summit Routes. And if you are in AWS, please take a look at the AWS security maturity roadmap that he published at the end of May. I believe this is the 4th or 5th version. It runs over a great number of ways to secure AWS. Looking at that last chart, like, where do you get started? He gives a great overview on some of the different ways that you can get started. So if you're responsible for knowing what's connected, like, how can you actually keep all of this data secure? You can actually also sign up for a Shodan account. They have a developer version, they have a free version. They also have a new product, semi-new, called Monitor. You can submit a domain, you can submit IP addresses, and they will automatically send you the results that they have for what they can see based on your assets that you want to monitor. They will check for IoT devices. They'll check for SSL changes. They will give you a portal of all the different domains and subdomains that they found from certificate transparency, MX, records, etc. Great, easy way. They can also email you. You can set up multiple email addresses. So if you want to sign up for it personally and throw in your work email, you can do that. I know from experience. So what are some of the other open source tools out there that you can actually use to help get an idea of what you have exposed? So from Bishop Fox, they just spoke at Virtual Black Hat in 2020, talking about Smogcloud, the cloud that no one wants. This is a really helpful tool that will actually find assets in all of these different services across your AWS accounts. Ideally, you can run this with a single account, depending on how you set up your AWS accounts, if you actually have permissions across all of your sub-accounts. They also have put together a number of different bash scripts if you need to put together a number of different API keys, etc. Check them out at github.com. You can download that and run that today. If you follow that, you can also see the full presentation from Black Hat as well. Well, that's a great way to see what you have out there. If you're more worried about checking to make sure that you don't release anything publicly, check out Conftest if you're writing infrastructure as code. Conftest is started as a separate project and is now part of the Open Policy Agent project from CNCF. They were recently accepted to be a subproject of OPA. Conftest is great. You can write your own policy using Rego from the OPA project. You can check for all sorts of different policies. It's a full language, so you can make as basic or as complex as you want using Rego. You want to make sure that you only have certain ingress or egress rules. There's a great blog that Praetorian Security just published talking about how they're using DevOpsSec. DevSecOps practices to actually manage their red team infrastructure. When they're spinning up their infrastructure, they want to make sure that it can't be overtaken by someone else while they're trying to overtake their own their client's infrastructure. So they're actually using Conftest, Terraform, etc. You can go through there and see what are the different things that you can do to make sure that your infrastructure is secure. So we talked about S3 before. S3 is so much better than it used to. You can actually have a great view if you actually log into the console, etc., to actually see whether or not all your different S3 buckets are public, whether they can be public, whether objects are, whether you can, there's now great rules that you can set up to block public access at the organization level, at the account level, or even at the bucket level. If you have a ton of accounts and you don't know where to start, Databricks just published a great guide called Bucket Brigade, talking about their process from going to, we have a S3 bucket exposed, to all the way to making sure that they actually have a Lambda function that's automatically checks for any objects that have been uploaded or modified for secrets, etc. So they have a multi-part step process that they all released on GitHub to do this. Step one allows you to scan every single S3 bucket you have. Step two is the automatic checking. There's S3 secret scanner. And step three, which very rarely you ever see in any of these projects ever, they actually have sample documentation for some of the things that they put out there, from policy to even just the emails, et cetera, that they use to announce to the different service owners. Highly recommend this if you are interested in securing your S3 buckets and you don't know where to start, or using even part of this if you do. This one was a really interesting thing that I found from Darkbit, something that they called simple DLP for AWS S3. One of the things that they found in like BITR attacks is that one of the common TTPs is that a threat actor will actually copy data from the account that they're attacking, such as your organization, to their own S3 bucket in their account that they control to help save on network transfers, etc. And so what Darkbit did was string together CloudWatch, SNS, Lambda, and eventually Slack to actually put together full monitoring for exfiltration on any changes to data in S3 buckets. They monitor for copy or sync events, which create the same CloudWatch event, can send those through and then immediately alert in their Slack channel. One of the things I really like about this is that it really puts in an idea of all the different things that you can do for this type of pipeline if you're running in AWS. This is pretty straightforward from looking at specific CloudWatch events. So if there's other CloudWatch events that you regularly look at, I would highly recommend to take this model, modify it slightly, and you can have your own specific monitoring pipeline for CloudWatch events. Yeah, so one of the things I would definitely suggest, like especially if you're using something like this, and you have the time, build out alerts that should never ever fire. So that way, instead of dealing with like alerts that fire like every minute and causing toil and extra headaches for your teams trying to sift through whether or not these are worthwhile, build up the ones that you absolutely know should never fire. So you know these are highly useful and high signal and low noise. This was another like really interesting post that I liked from WW Tech, talking about how they built out their AppSec platform in a modular, scalable way, using mostly open source tools. So their internal AppSec platform does discovery of public web assets, performs port scanning, fingerprinting, and other reconnaissance, and launches security scanning to identify potential risks. This is a great post to review, kind of thinking about, well, where can we start if we're not doing this? How can we start to like bring in like this part of the AppSec platform that we're all already doing? I'm a huge fan of Amass and Subfinder. If you've never run these before, I highly suggest like running those after this talk. And you might be shocked at the amount of public information that is out there, especially since now with certificate transparency logs. Amass and Subfinder go through and find out all the different OSINT information, open source intelligence that they can, from whether it's subdomains that have been created, whether it's from certificates for different services, etc. And they give you a great overview of what is public out there. They also, in this post, is also like super helpful because it breaks down into like modular pieces and gives you like a quick bites on like, this is how that you can think about this. If instead you're like, all of that is like old hat, I'm already doing all this, Uber has raised the bar, talking about their command service using Dow Jones's Hammer. They took a two-part write-up on Medium, talking about how they used Hammer, which is an open source project by Dow Jones, composed of a collection of Lambda functions written in Python. These Lambdas act as configuration violation checkers across AWS accounts and aggregate all the findings in the easy-to-manage set of DynamoDB tables in a centralized account. Command then calculates vulnerability ratings, runs it through a number of duplication and Uber-specific tools to create more manageable tickets, actually assigning tickets directly to the service ownerships based on the ETL pipeline that they had built as a part of all of this. There's a ton to digest in here, even just taking a look at Hammer. If, again, you are in AWS, they have that posted on Medium as well. If you're multi-cloud, or even if you're single cloud, I would definitely take a look at ScoutSuite. As of late last year, they now support most major cloud providers, including Alibaba, Oracle, and of course, AWS, Azure, and GCP. This is built by NCC Group, and it outputs a lovely HTML report, as you might expect a consulting firm to do. Broken down by different action areas, highly highly recommend this if you need an idea of what's going on across your different cloud providers. If you are on just GCP, I would take a look at Forseti Security. Scans your entire GCP infrastructure, in inventories, everything. It has monitoring, alerting. They have a number of built-in rules. You can use OPA to build out more rules. It runs as always on in your GCP infrastructure. You can create this as a sub-project. I actually wrote a getting started guide to Forseti that you can check out on our blog from a few months ago. You can run this with Terraform and be up and running in a matter of a few hours and having alerts going to Slack, going to email, and a number of different notifications. Check out the blog. Please give me any feedback that you might have. So we kind of looked directly at some of the data at some of the cloud providers, but Kubernetes, it's really the gateway to data at this point. So we looked at some of the different options here for managing your Kubernetes infrastructure. So as we go up the stack, let's look at like more the actual infrastructure itself that we've deployed. Darkbit.io, again, they have an awesome tool that they released called MKIT, or the Managed Kubernetes Inspection Tool. It runs across Azure, EKS, and Google Kubernetes Engine. Or if you're running K8s by yourself, you can also run it against there. It gives you a great scan to give you an overview of how you are doing with setting up your Kubernetes infrastructure. If you are big onto GitHub Actions, Sysdig released something called the K8 Security Config Watch, actually running on GitHub, that can review your configs during pull request time and actually have security as code, flagging things as your developers, as you commit things, to make sure that you are committing what you expect and making sure that it's secure. If you've been running Kubernetes for a while, you may have been running pod security policies. InfraCloud has released an awesome blog talking about how you can actually translate your pod security policies to OPA, Open Policy Agent, making them even more having even greater control over your pod security policies with the backing of OPA and Rego as well. So if we think about the API, we take a step back, and because I know not everyone is dealing directly with like the infrastructure. So one of the things I found was that just released this year is something called API Check from BBVA. It's an environment for integrating a bunch of different HTTP API tools and creating execution chains easily. Your APIs can return sensitive data as well for different entry points. Sensitive data could be user information, data from business logic, internal IPs, and such. This tool analyzes request response content and headers and tries to find sensitive data in both the request and the response. They have a number of different modules, such as sensitive data. They have a replay module. If you are interested in checking out or responsible for making sure your APIs are safe and secure, be sure to check them out. Also this year, Yelp released Fuzz Lightyear. I think that they win the naming out of all the tools in here. but it is a tool for automated IDOR discovery through stateful Swagger fuzzing. So if you are using Swagger, this tool helps to start to dig into your APIs in a more in-depth way. Check out both of those tools today. So we kind of looked at applications, we've looked at infrastructure, but everyone's using Git. So one of the brand new tools released this year is something called Git Hound. It talks about how, so this was released by a security researcher after using it for finding secrets in GitHub and receiving over $7,500 in bounties. Git Hound boasts a unique scoring system in comparison to a number of different tools. GitHub is actually in the process of building out their own tool that's currently in beta, but until then, check this one out. A couple years ago, AWS Labs released their own secret finder. You can actually integrate this into your CI/CD pipelines. And OWASP also has their sedated project that can check Git for secrets as well. And if you are using Git and worried about leaking secrets, check out the blog from Git Guardian on what to do from announcement of leaking secrets to changing secrets, modifying history, etc. If this is something that's on your plate, take this, turn this into a playbook, and be able to have this in your back pocket should you ever, and hopefully you won't need this if you ever do accidentally leak secrets. One of the last tools we're going to look at is Slack Watchman. Data is everywhere. Sensitive data is everywhere. And if you use Slack, you're probably in Slack as well. People are probably sharing passwords. They might be sharing credentials, keys, private keys, bank cards, quickly sharing certificates, private keys, etc. for SSL, docs. Paper Mountain released something called Slack Watchman that you can set up as an app to actually monitor Slack based on some regexes for any of these different types of things. Finally, I want to talk about our brand new open source project called Approzium. We've just released to help developers improve observability and security of their applications. It allows applications to connect to databases without requiring access to credentials. It emits logs, metrics, and traces with enriched information about their runtime execution context. It is built as a lightweight open source library with multi-language and multi-cloud support. So what exactly is Approzium? It is two components. It is comprised of two components that are deployed independently. An SDK that runs as part of the application code, and a standalone service called the Authenticator with which the SDK interacts on behalf of the application. A single Authenticator instance can support multiple applications, which may be set up optionally as an auto-scaling group for load balancing and high availability purposes. The SDK has the ability to query infrastructure metadata services native to various cloud platforms and to orchestration frameworks such as Kubernetes to generate rich execution time context about the application. This integrates with whatever sort of password manager, such as vaults, AWS secret managers, as well as the cloud native IAM credential manager as well. So what do we get from when we talk about observability? Every database authentication request is assigned a request ID, which is included in all logs generated by the request. Approzium also handles a number of metrics, both directly security and non-security related. Standard metrics include total number of requests, responses, errors, and timing gauges. One of the great things about this, as far as observability goes, this means that you're no longer using the same username and password for every individual piece of your microservice. So if you have the credit card microservice that all use the credit card username, now with using Approzium, you can actually get full logging that says which instance was actually connecting to your database, as opposed to just that the credit card user was. Approzium also supports passwordless authentication. You can actually use your cloud provider's built-in identity. For example, normally you can't use an AWS IAM role to authenticate to a database you're running yourself, but with Approzium you can. Approzium is also agnostic about your secrets manager, whether you're using Vaults, AWS Secret Manager, etc. As the application never receives the password, it's impossible for the application itself to accidentally expose it. You can also limit access to your secret manager as well. If your application no longer needs direct access to your secrets manager, now you can cordon off that to just the authenticator service, as opposed to the application should it get breached. And being able to pull the API keys and pull even more information from your secrets manager. So currently today, it supports Postgres, MySQL, RDS, MariaDB, Aurora, Python, AWS Identity, Vault, AWS Secrets Manager. Coming soon, the team is working on GCP and Azure Identity, Mongo, Redis, GCP and Azure Secrets Management, tracing, and more. Feel free to follow along at approzium.com and go ahead and download and check it out today on GitHub. I'd like to send a special shout out to the core maintainers, Timothy Nguyen, Becca Petrin, and Dio Gatto. They have done an amazing job with this, and I can't be more proud of them and how awesome this project is. So we've talked a lot about different tools, and this all assumes that your developers that you're working with, all know what are the basic security measures that should be in place to actually secure everything. If not, I would check out the cheat sheet series from OWASP and their database security cheat sheet. This gives a great overview on base configurations. If nothing else, circulate and use this as a teaching tool. And check out the rest of their series. They've done an amazing job with a ton of different technologies that give you a great primer, or that you can use in your training, or circulating to the rest of the team. Finally, it's 2020, and these products are actually providing worthwhile documentation. Finally, shipping things with secure defaults. It doesn't always help, but if you are responsible for securing any of these, definitely take a look at the official documentation. You can see all these links here. But definitely take a look at each of these documentations. No one wants to be the company that is indicated in every data breach, and so they are actively making better guardrails and better secure defaults. And now I'd like to open up to questions. Follow me on Twitter, DanT24, and check out our website at Cyral.com. and our blog at cyral.com/blog.
So Daniel, can you hear me? Can you guys? Oh, okay. So yeah, so you mentioned Shodan, right, at the start.
Yeah.
And if you use Shodan, it normally gives us the IP address of whichever device we're trying to search, right? So if we try to map Shodan with a cloud service, how do we find the exact domain? Like you can look at the certificates individually, but they could be mapped to different organizations, one particular IP shared certificates. So how do we use Shodan for AWS or any other cloud-based shared infrastructure by multiple organizations?
If you're looking for your own domain, you can do that with the monitor portion of Shodan. That's how I've used that.
Okay, because like you showed those MongoDB instances, right? So if you want to identify that, okay, there are so many MongoDB instances for Alibaba and all those, but it shows Amazon also. So it could be a third-party organization which is running Amazon AWS and whose MongoDB instance is popping up in Shodan, right?
Yeah. It doesn't. It just uses the IPs to say like who is backing that. It doesn't actually say like the who the customer is of AWS or Alibaba.
Okay, so if the certificate for that particular IP address were to give us the information for that owner, then that might be the only option. Otherwise, we would have to sift through the data to find out who the actual owner is, right?
Yeah, if you're looking for the owner, yeah, you would have to search through the data, etc. If you're looking for your own stuff, you can use the API and pull down, say, a list of your IPs and then reverse search them in Shodan instead. But if you're looking more at the attacker route of like, I just want to see like who's the owner of this Mongo database, you would have to search through that, see if there's any other interesting information for that IP address.
Okay, and also I wanted to ask you, like, if you come across Cloudflare and any other DDoS mitigation service, many of the times, like if you try to access the IP address directly, it doesn't allow you to do that. So that kind of reduces the attack surface as far as the showdown results are concerned, unless you were to actually find out the specific subdomain mapping to that particular IP address to access the database, right?
Yes, I believe so.
Okay, thanks. So, Daniel, apart from AWS, like for you mentioned, like one of the big players is also DigitalOcean, and you also mentioned resources for GCP. I think it was some Forsec night or something like that. But do we have any? Do you have any resources to share for DigitalOcean, because that is a big player as well in the cloud service? So
I don't have anything directly for DigitalOcean now.
okay.
I do have to. They do have an amazing blog, but I haven't really dug into their services directly.
And also, apart from Shodan, what do you like? Do you recommend sensors also?
Yeah, I mean that's also interesting. Shodan is just kind of the most well known at this point. There's a couple other services out there that are kind of doing what Shodan has done, but yeah.
Okay, thanks.
If we don't have any questions, I think we can end the session.
Yeah, thank you. Thank you all for coming out. Contact me on Twitter. I'm on LinkedIn, on the Silicon Valley Slack as well. So yeah, if you have any questions, feel free to reach out. Thank you.